So my register number is URK17CS174, and this is the 7th experiment in the data structures and algorithms lab, and this is the experiment about merge sort and quick sort. So in our class MQ, which stands for merge and quick, we have four functions. We have a merge function, and we have a merge sort function, we have a quick function, and we have a partition function. So first we'll going through the merge sort function. The merge sort function takes three parameters: an array, pointer, int low, and an int high. So basically in a merge sort function we'll be calculating the mid for every array, and then if the low is less than high, we will be passing the merge sort of a of lower mid and a of mid plus 1. So basically dividing the array into two parts, one which is less than the mid and one which is greater than the mid at each stage, and then finally after every result we will merge both the lower part and the higher part to make our final array. So this is how our merge sort function works. From this we are calling our merge function. So in the merge function what we do is we send our array, our low, our int, high, and our mid, and we declare the variables that we need. And what we'll be doing is we'll be comparing at each step the results from the lower half and the upper half of the divided array, and based on the condition, if the a of I is less than a of j, we'll be assigning the temp of k equals a of I. So which one is lesser, we'll be assigning to the temporary array. Otherwise we will be assigning a of j to temp of k. And after that procedure, what we'll be doing is we have to assign the left out elements again into the temporary array. So for this we will be starting loop from I to less than mid. So this will run from 0 to mid, so not 0, from the I value to mid, and we'll be assigning every value to the temporary array. And after that we'll be assigning the remaining values from the mid to the the j value to the high, and we'll be doing this over here. In the end we will equate our temp values to our a of I. So finally we'll have the sorted array in a of I. So this is how the merge sort works. The other two functions are the quick sort functions. So this is our main quick sort function. Here again we'll be taking an array, low and an upper value as the arguments, and we'll have another integer here j to help us with the operation. So what we'll be doing is we will partition our array. Basically we'll be selecting a pivot and partitioning the array around that pivot, and then what we'll do is we will sort those two based on the partitions. So from here we go to the partition function. So this is a partition function which basically takes three attributes, three parameters, an array, a lower, and an upper variable. We declare the variables that we want. And in the quick sort function what we do is we have a do while loop here, and inside this we will partition our array, and using the partitioned element which is our pivot, using the pivot we will be organizing our elements based on that. And finally after this we will be sorting the partitions and returning the value here. So we will check if, which one is lesser, and if I is less than j we will be swapping the two values, hence sorting the two partitions, and later we'll be returning the value to the upper function here. So hence we'll get a sorted array. So then in our main program we create an object for the class, and we take the input of the array, and later we pass it to the merge or the quick function using the switch keys. So let's run this program. So I'll be entering 5 elements first. Let's say I enter 40, 50, 6, 69, 7, 23, and -2. And first I will do a merge sort. So as you can see, the sorted array we are getting -2, 23, 40, 50, and 69. So merge sort is working properly. Now we will pass similar inputs to the quick sort. So again we have 5 inputs. So -2, 40, 50, 69, and 72. And this time we will be doing quick sort. As you can see, we are getting the same output here. So basically both the sort functions are working properly, and this is the end of the 7th experiment in the data structures lab. Thank you.